Joshua Nowicki took this photo of Chicago from 55 miles away. If we lived on a ball 25,000 miles in circumference, the tallest point of the tallest building would be below the curved horizon of the Earth. Even people who believe we live on a ball know this is true.
This photo from Grand Mere State Park, this is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. Chicago's beyond the horizon, should not be able to see it. So typically we would not be able to see this. This image would be viewable from much, much higher in the sky, up in space.
So we all agree that we wouldn't be able to see Chicago from 55 miles away on the ball Earth. But how do the globe believers know that we're seeing a mirage? Is there some quality or characteristics in the photo that indicate it is a mirage? Nope. The only, quote, evidence that it's a mirage is that we wouldn't be able to see the real thing from that far away on the ball Earth. So let's try to unpack what's actually going on here. This is a diagram from an online Earth curve calculator. The idea is that the blue arrow represents the observer, the dotted line represents the observer's line of sight, and the red arrow represents how much of a distant object would be hidden from the observer behind the curved horizon of the Earth. So what that meteorologist was saying is that Chicago is here, on the other side of the curved horizon from Joshua, and so he wouldn't have been able to see it unless he was way up in the air looking down over the horizon. But since Joshua was not way up in the air, the explanation is that the light waves from the Chicago skyline traveled along the curve of the Earth for 50 miles to the point where Joshua was able to see that light manifested as a perfectly formed right-side-up mirage of Chicago on his horizon 5 miles away from him. Why do I say 5 miles? Because if we live on a ball of a set size, the horizon is also a set distance from the observer, depending on the height of the observer. So, for example, if your eyes are a foot above the ground, the distance at which the curve of the Earth prohibits you from seeing any more of the Earth's surface beyond it is 1.22 miles. That is your horizon, period. If you stand up and your eyes are 5 feet above the ground, your horizon is now 2.7 miles away. Period. There is no wiggle room because on a ball, your horizon is always the physical point of the curve that you can't see around. So in any Earth curve calculator like this one, if you set the observer's height to, say, 10 feet above the ground, then this point absolutely must be 3.87 miles away. Joshua Nowicki was standing on a sand dune near the edge of Lake Michigan when he took this photo of Chicago. I'm estimating that his eye height was 17 feet above the lake, and therefore his horizon was 5 miles away from him. But it's important to remember that the distance to the horizon is set in stone in the ball Earth model. If your camera is 3 feet above the surface and you're seeing the horizon at, say, 20 miles away, then we simply don't live on a ball. In the real world, a person's horizon is anywhere the ground and sky converge in the distance. Which brings me to my next point. All of these Earth curve calculator graphics have the observer's eyes high above the surface and looking down to the horizon, because in the ball Earth model, that's how it would work. In reality, the place where ground and sky converge into our horizon is always at eye level, never at foot level or below. And anyone can verify this for themselves just by standing on a beach like this person and observing that the horizon is here at eye level, not here at foot level. Anytime you have an unobstructed view to the horizon, it will be at eye level, not at foot level or below like this graphic shows. It is an effect of how our eyes work, and even elementary school children learn about this effect of perspective in art class. Things to the left of the observer converge right. Things to the right converge left. Things above converge down, and things below converge up, resulting in a horizon that is at our eye level. And this is how it works no matter how high up we go. The horizon is at our eye level from the beach, from the top of a mountain, from 7 miles up on an airplane, from 15 miles up on a high-altitude balloon, and even from 24 miles up during the Red Bull Edge of Space jump. And that simply wouldn't be if we lived on a ball. This graphic shows the reality of the ball Earth model correctly. On a ball, we would be looking down to the horizon. Farther down, the higher up we went. They even have a name for it, horizon dip angle. And let's face it, if a person standing on the beach is really looking down to the horizon, then they'd have no choice but to be looking farther down the higher up they went. But airplane pilots have a saying, keep it straight and level. That means pointed to their destination and level with the ground. And they keep it level with the ground by keeping the nose of the plane even with the horizon. They even use a gyroscope, which is linked to an instrument in the dashboard that allows the pilot to keep artificial wings level with an artificial horizon so they can continue to fly straight and level when they can't physically see the real horizon. So no, nobody is looking down to the horizon. We would do that if we lived on a ball, but nobody has ever stood on the beach and seen their horizon at foot level. Actually, it would be lower than foot level, because on the ball Earth, if your eyes are 6 feet above the surface, your horizon is 3 miles away. But in that same 3 miles, the Earth you are standing on has curved away from you by another 6 feet. So in reality, you are not only looking down the 6 feet from your eyes to your foot level, but also the 6 feet that the surface of the Earth has curved away from you over that 3-mile distance. Your horizon would be 12 feet lower than your eye level just standing on a beach. And the higher up you went, the more you'd have to look down to the surface, while the surface itself was curving farther and farther away from you. From a commercial jet, you'd not only look down the 7-mile height you are above the ground that is straight down below you, but also another 7 miles that the Earth itself curved away from under you over the 230-mile distance that your horizon would be away from you. Your horizon from a jet airplane, the thing the pilot is aiming at, would be 14 miles below your eye level. Compare that to reality. Our horizon is always at our eye level. It is a product of how our eyes work. Another product of how our eyes work is that we see distant objects as smaller than they actually are. But this is an effect of how our eyes work, not how light travels. So if Joshua was seeing the actual Chicago from 55 miles away, it would appear very small, as it does in his photo. However, if Joshua was seeing a mirage of Chicago on his horizon only 5 miles away, then the mirage of Chicago would appear to him as if he was seeing the actual Chicago from only 5 miles away, because the light from the actual Chicago would have traveled along the Earth for that 50 miles to Joshua's horizon as actual size. The light itself wouldn't have shrunk down in size just by traveling across the Earth in a straight line. This is Joshua's Chicago photo before he cropped it. In the uncropped version, notice how far away Chicago appears to be. Joshua also used a 200mm zoom lens, which makes objects appear to be 4 times larger than how our naked eyes would see them. Here I've shrunk Chicago down to 4 times smaller, and I ask you if you think that's what Chicago would look like through your naked eyes if you were physically 5 miles away from it. The Chicago Joshua would have seen through his 200mm zoom lens would look like this, not like this. This box represents the 2-mile wide Chicago loop in Joshua's photo. According to modern science, the light from Chicago would travel in a straight line and reach Joshua as the same exact size as Chicago itself. If Joshua was able to see the source of that light 55 miles away, the angle at which the source of the light would enter his eyes or his camera would be very small and would be interpreted as a very tiny Chicago. On the other hand, if Joshua did not have a direct line of sight to Chicago, but was instead seeing a mirage on his horizon only 5 miles away, the mirage would have been the same size as the actual Chicago, since it was created by light traveling across Lake Michigan in a straight line and at the same size as the actual Chicago. The mirage would have looked like this through his naked eye, not this. And it would have looked like this through his 200mm lens, not this, because the shrinkage happens in our eye. The light coming from Chicago doesn't shrink down as it's traveling away from Chicago. it will continue to travel at actual size, theoretically forever, unless it is absorbed by something. So the Chicago light that reached Joshua's horizon would have been the same size as Chicago itself, and it's clear that this is not the case. But it absolutely must be the case if the Chicago in his photo truly was a mirage resting on his horizon 5 miles away and photographed through a 4x zoom lens. Instead, the photo through his zoom lens shows a very small Chicago that looks exactly like the actual Chicago would look from 55 miles away through a 200mm lens. The only logical conclusion is that Joshua Nowicki took a beautiful photo of Chicago from 55 miles away. And since everyone agrees that this would be impossible if we live on a ball 25,000 miles in circumference, the only logical conclusion is that we don't live on a ball 25,000 miles in circumference. And the same thing applies to every single flat Earth observation in which we can clearly see something on our horizon that should be hidden behind the curve of the Earth. If you're going to claim that an inversion layer can trap light and force it to follow the curve of the ball Earth, allowing us to see a mirage of a distant object on our horizon only 3 miles away from us, then you'll have to explain why the mirage, at only 3 miles away, has the same apparent size as the actual object does when seen from 50 miles away.